So what is continuity of a function?
It's
It
like
basically,
if
what do
if
you
it
understand
like
about it?
if it goes to infinity, I guess.
No, no. Continuity means, so basically so we say that a function f of x is continuous at any point x equals a, for example, if all three of these conditions are satisfied. Number one, the limit as x approaches that a value of the function exists.
Mhm.
So like obviously the function needs to be approaching something at least. Number two, the function's actual value at that point also exists. Okay? And finally, the limit as x approaches that value must be the same as the function's actual value there. What does this mean? For example, if you have a function that's going down from here and up from here, if you ask me what's the limit as x approaches 0 in this function, I will say it doesn't exist because from the right side it's going up, it's from the left side it's going down,
Yeah.
right? When you come to x equals 0. So the limit needs to exist, meaning the function must be approaching the same y value from both sides. Okay? So like for example at this point now the left side and the right side limit is the same. So that means it exists. Because remember I told you that to check the existence of a limit, check both sides. Check both the one-sided limits and see that they're equal. So the function must be approaching an actual number from both sides. The second thing is that the function must actually exist at that point too. Like for example, if I want to check if a function is continuous at this x value and the function hits a hole there, then that is not continuous. It hits a hole. It's not like it doesn't even exist there. How could it be continuous? Okay. So the
Yeah.
function must exist at that x value. And finally, this is the most important one. The function must be approaching the same value that it's actually at that point.
Mhm.
Okay? So you cannot have any stupidity like this, for example. Like the function's actual value is 0 here, but it approaches 5. Okay? So you cannot have this. This is clearly not continuous because like it doesn't even feel continuous, like from the loose English definition of the word.
Yeah.
So the function must be the same value as it is approaching at this x value. Okay?
Mhm.
So essentially, this is a complete thing, You need this to exist and this to exist and both of them to be equal. Does that make
Yeah.
sense? Good.
Clear.
So let's now you notice that this definition of continuity is only for specific x values. So does this mean that for a given function, if I want to prove that the function is continuous everywhere, I will need to check this for every single x value? There's infinite x values. That doesn't make a lot of sense,
Yeah.
does it?
Yeah.
Right. So what we do is we realize that some functions are always continuous. Okay?
Hmm.
So for example, all polynomials are always continuous.
Yeah.
Polynomials meaning anything of this form. You know, no fraction, no square root, no nothing, just plain old powers. These are always continuous. Okay?
Yeah.
There are a few others, but for your case, this is sufficient. Just remembering that polynomials generally are continuous everywhere. Okay?
Mhm.
So are always continuous at all x real values. Okay? So this will be kind of something that helps us. Now, still, what if it's not a polynomial? What if we have to check like some other kind of function? Okay? So let's take a look at a problem. Eh. So before we do that, let's talk about the types of discontinuities.
Mhm.
There's three types. Number one, you have the whole. When does a whole form? The whole forms, let me type it out, when there is a cancelable factor at the numerator and the denominator. What does that mean? So, for
When
example,
when there's like for example 2 minus x in the numerator and 2 minus x in the denominator.
exactly.
Yeah.
For example, this case, right? You see this guy appearing at the top and the bottom. It can be cancelled out. This means that this will form a whole at, so forms a whole when x minus 2 equals 0, meaning when x equals 2. So this function will have a hole, a missing point at x equals 2. Okay?
Yeah.
Because of this guy's presence and the fact that he's cancelable. Okay? Not only is he
Mhm.
there, he can also be cancelled. Those two things together make a whole. Now, what will this graph look like? There's a funny thing about holes. If you cancel them and you make like, and you look at the function after cancelling them, the function with the hole will look exactly the same.
Yeah.
It'll look like this. However, there will be a hole when x equals 2. So right there will be a missing point.
Hmm.
Okay? So the function stays the same, the shape stays the same, the behavior stays the same. It only just includes a hole at x equals 2. Okay? That's all you need to know. Number 2, you have asymptotes. These happen when the factor is not cancelable. When factor in denominator is not cancelable. For example, 4x plus 1 over x minus 2, x minus 3. Or let's not make it 2, let's just do 1. There. This guy forms a asymptote at x minus 2 equals 0, so x equals 2. What will this function look like? I'm not sure, but it will have a vertical asymptote right there. Okay, maybe the function will look something like this then. Okay, so this is how you know an asymptote is going to form. Is this clear so far?
Yeah.
Okay. By the way, as you can see, discontinuities essentially mean when the function is broken.
Yeah, exactly.
Okay. So by the way, earlier in this example, we could also see that there will be an asymptote at x equals -1 because of this guy who could not be cancelled, right?
Mhm.
X equals -1, asymptote basically at x equals -1 because of this guy, because he's not cancelable. Okay.
Yeah.
And then finally we have the jump discontinuity, which is very easy to see. It will come always from piecewise functions. So jump discontinuity. When the function is piecewise and the y values don't match at the point where the behavior changes basically. For example, it's x plus 2 when x is positive, but it x minus 10 when x is negative. The function looks something like this. What does x plus 2 look like? It looks like this line, right?
Yeah.
But we only want the positive part of it. What does x minus 10 look like? It looks like this line, but we only want the negative part of it. And we don't
Yeah.
want the part at x equals 0 either. So this point is -10 because the y-intercept was -10, and this point is 2. As you can see, from the left-hand side, the function is approaching another y value. From the right-hand side, it's approaching another value. So this is a jump discontinuity. Okay.
Yeah.
These are all the types of discontinuities you need to know about. Now let's talk about uh, how to make a function continuous. So what can we do to make a function continuous? Here. So if you want this piecewise function to be continuous, you would want that the y value from the left-hand side is the same as the y value from the right-hand side, right? So we
Like
would want, uh-huh,
during my note taking, like by myself, I I got like there's three points to make sure a function is continuous. So like when the limit exists, when f of a is defined, and when the value of the function matches the limit.
Yeah, exactly. So to make
Mhm.
this continuous, that's a very good point. The thing is, what is f of 2 in this case?
It would be the first function.
Exactly. 2 times 2 plus 7, which is like 11, I think. Root of 11. Okay, good. So the function's actual value exists there. What's the
Hmm.
limit as x approaches 2 in my function? We need to think about it from the left and the right hand side, right?
Yeah.
Okay, good. So let's talk about it from the left side first. Which function should I use for that?
The left side would be your second function.
Mm-mm. When x is less than or equal to 2, I'm approaching from this side, right? So this
Yeah.
first one, because I'm approaching from left of 2, so from less than 2. That's why I'll
Yeah.
use the first. So it's gonna be 11, a root of 11. Okay, so the left-hand side limit is root of 11. What's the right-hand side limit? For the
The right
right-hand
hand
side
side.
limit, I'll use the second function, right?
Yeah.
What do I want this to be equal to, though? So first, what is this equal to?
Um, you want it equal to 2.
No, I want it to
Also
equal to,
square root of 11.
yeah. But what is
Yeah.
it equal to right now? If I plug in the limit
Uh,
directly?
it's equal to uh 2.
Mm-mm.
So yeah.
2 square minus 2 plus k.
Or what would k be?
We don't know, that's what we're looking for.
Oh
So
yeah.
first, let's write down what it is in terms of k by plugging in 2. What is it going to be?
Mm-hmm.
So if I plug in 2, what's it going to become? Remember, k is an unknown right now, so I'm
K.
only going to write it down in terms of k, so
Mm-hmm.
that k stays. So plug in 2 and tell me what this becomes.
Uh, so it'd be 4
4.
minus 2 plus k.
Exactly. So 2 plus k then, right? Because 4 minus 2 is 2, right? 4 minus 2 plus k. So 4 minus 2 is 2. So I just simplified it. So far so good.
Yeah.
Okay. Now, first of all, if we want the function to be continuous, we need this to exist and be equal to the function value itself also, right? Like we want the limit as x approaches 2 to exist, right? And for it to exist, this must be the same as that, correct?
Yeah.
And on top of that, we also need it to be equal to root of 11, which is the same as me saying ultimately that if I consider all of these facts, all of these three things must be equal for continuity, right?
Mm.
So root of 11 must be equal to 2 plus k for continuity,
Yeah.
which means that k must be root of 11 minus 2. You see?
Mm-hmm.
So that's that. Now let's do a problem. Um, hmm. So can you try to do question number 1 to begin with?